Hey guys, all right, so I'm just gonna go over how to do the questions from the Unit 1 review sheet. Now, if you got a question correct, you can just fast forward past that part of the video and just scroll to the ones that, you need help with. All right, so if we take a look at number 1, now, the first thing you wanna say to yourself, always when factoring is, can I factor out a greatest common factor? Now, if we look at these three terms, there's nothing that we can factor out. So we have a trinomial, three terms, where the leading coefficient is something other than 1. So what we're going to do is we're going to make our rainbow, and we're going to do factor by grouping. All right, so let's do that. So we make the rainbow, and what we do is we multiply together 4 times negative 63. So that'll give us negative 252. Okay, so what we need to do is we need to come up with two numbers that multiply to negative 252 and add to positive 4. Okay, so this could be a pretty hard one because, there's a lot of numbers that multiply to negative 252. Or, it's a pretty big number. That's actually what makes it hard. But if you remember, we talked about a calculator trick that we can use. Okay, basically you go to y equals in your calculator and you plug in the number you want it to multiply to, so negative 252 divided by x, and then you're going to go to the table of values. So you're going to look and you're going to say, well, this is one pair of numbers that multiplies to negative 252. Does this add to positive 4? No. All right, so then here's another pair, 2 and negative 126. Does that add to positive 4? No. So you're going to keep going down the list, until you come up with two numbers that do add to positive 4. And look right here. This is really small on here, but 18. Let me actually see if I can make that bigger. There we go. Okay, 18 and negative 14, right here, 18 and negative 14, they add up to positive 4. So these are the two numbers that we're going to use. All right, so what we're going to do is I'm going to come back over here, and I'm going to bring down my first term. I'll leave a big space and bring down my last term. And I'm going to break up this positive 4x into 18x and negative 14x, okay? If we attached x's to each of these and combine them, they would combine to give us 4x. That's why we're allowed to break it up into positive 18x and negative 4x. Okay, and then from here it should be pretty straightforward. So we're going to group together the first two terms, and we can factor out a 2x, which would leave us with 2x plus 9. Now out of the next two terms, we can either factor out, that's supposed to be a 14, not a 4. Okay, we can either factor out a negative 7 or a positive 7. Now, since this is positive 2x plus 9, we're going to also want to be left with a positive 2x plus 9 in parentheses. So we want to get rid of these negatives. We're going to factor out the negative 7. And when we do, let's check it. Negative 14x divided by negative 7 is positive 2x. And then negative 63 divided by negative 7 is positive 9. All right, now we know we're on the right track because these match up. So we're going to take what's outside of our parentheses, the 2x minus 7, and we're going to group those together in one parenthesis. And then we're going to rewrite this common binomial of 2x plus 9, and that'll be our other factor. Okay, so then this is the answer. If you wanted to check, you could always double distribute and combine your like terms and see if it leaves you with the original expression. All right, let's take a look at number 2. Now we're going to start number 2. We're going to say the same thing to ourselves that we say every time we factor. Can I factor out a greatest common factor? So when you look at these terms, yeah, look at that. All of these numbers are divisible by 3. And also, since they all have a's, this only has one a. We can pull out an a. We can pull out that one a. So we're going to factor out a 3a. Okay, so in parentheses, we're going to be left with, well, I'll do this one slow. This is how you do it. 6 divided by 3 is 2. And if we had a cubed, it means we had 3 a's being multiplied together, but we pulled one of them out. So that means we have two a's being multiplied together left. So we write that as a squared. And then you can bring down the plus sign. 15 divided by 3 is 5. And we had two a's being multiplied together, but we took one of them out, so we still have 1 left to put in the parentheses. And then bring down the minus sign. 21 divided by 3 is 7. And we had an a, but we took it out, so we don't have an a left to put here. So we're going to close up the parentheses. Now we want to see if we can factor further. Okay, so we have a trinomial in here. And because the leading coefficient for that trinomial is something other than 1, we're again going to have to do the rainbow into factor by grouping. So when we multiply together 2 and -7, that gives us -14. So we have to come up with two numbers that multiply to -14 and add to 5. Okay, before I do that, let me bring down the 3a, and I'm going to open a parenthesis. Now, when we do factor by grouping, we bring down the first term. I'm going to leave a big space right here, and I'm going to bring down this last term. And once we come up with the two numbers that multiply to -14 and add to +5, that's what we're going to put here, along with this a attached to them. All right, so two numbers that multiply to -14 and add to +5 are +7 and -2. So we're going to write +7, and don't forget to attach the a to it. Whatever's here gets attached. And then -2 with the a. All right, so now let's see. I'm going to bring my 3a down, and I'm going to open a parenthesis, and we're going to group. I'm going to group together the first two terms and group together the last two terms. All right, now to these first two terms, looks like I can only factor out an a. I mean, you could write 1a, right? You could factor out a 1 if you want, but I'm going to just take an a out of both of these two terms. So I have to open another parenthesis and write what I'm left with. So if I take an a out of this first term here, I still have the 2, and I still have one of these a's, so I'm going to write 2a. And then I'll bring down the plus sign, and I'll bring down the 7, and close up my parentheses. Okay, now to these two terms, the only thing I could factor out is either a +1 or a -1. But since I have positives in this parentheses, I want to get these negatives out of here. So I'm going to factor out a -1. And then when I open up a parenthesis, -2a divided by -1. A negative divided by negative is a positive, so that's +2a. And then -7 divided by -1 is +7, so +7. And then I have to close that parenthesis, as well as, don't forget about this open parenthesis, we have to close that one too. If you don't like to have parentheses within parentheses, you can always make this a bracket on the outside instead. Okay, so to finish this up, I'm going to bring down the 3a, and then I'm going to group together this a and this -1, and that'll make another factor. And then I'm going to rewrite the 2a plus 7 as my final factor. Okay, so this right here is my answer. All right, so let's take a look at number 3. Now, when we look at number 3, what you'll notice right away is, look, the exponents should be in descending order, and they're not. So we're going to rearrange our terms. So I'm first going to write this negative k to the 6th and keep the signs with the terms. Then we have a positive 8k to the 4th. And then we have our positive 48k squared. Okay, so we're rearranging these so that the exponents go from the highest number to the lowest number. We want them in descending order. All right, now if you look here, it looks like the only thing we can factor out, they all contain k's. Okay, k squared is the smallest, that's the one with the smallest exponent, so we're going to take out a k squared. But in addition to that, it'll make your life so much easier. See how your leading coefficient is a negative? We don't want to have a negative if we're going to factor further. So instead of just factoring out k squared, let's factor out that negative as well. Let's factor out negative k squared. Okay, so then if we took the negative out and we had 6 k's and we took out 2, we still have 4 k's left. So that's going to be k to the 4th. All right, and then you can, I mean, you can, if you want to think about this as a -1 here to help you out, you can. You could say 8, positive 8, divided by -1 is -8. And we had 4 k's being multiplied together, but we took 2 of them out, so we still have 2 left to put in here. And then positive 48 divided by -1 is -48. And we had 2 k's being multiplied together, but we took them both out, so we don't have any left to put here. So I'm going to close up my parentheses. Okay, so now let's bring down, I'm not going to bring down the -1k squared. I'm just going to bring down -k squared. Oh, that's supposed to be a k. It's an ugly k. And I know some of you guys, when you see k to the 4th, you like to do the rainbow and factor by grouping, but honestly, there's a 1 as the leading coefficient. You don't have to. I would just say, look, this is a trinomial, so I'm going to set up 2 sets of parentheses. Since this is a k to the 4th, I'm going to put a k squared in the first spot in each parenthesis. And then I'm just going to come up with 2 numbers that add to -8 and multiply to -48. Okay, I know this is nitpicky, but this k is really annoying me, so I'm going to see if I can erase that. All right, how do I do that? Let's see. Here's the eraser. Okay, I'm going to change that, sorry. All right, so this is -k squared. All right, so let's go back to this. We're finding 2 numbers that that add to -8 and multiply to -48. You can use the calculator trick like I showed you in number 1, or you could do trial and error, however you want to do it, but it winds up being -12 and +4. Now, we always want to check to see if we could factor further. If you have 2 terms separated by a subtraction sign, you want to say, is this the difference? Yes, it is, of perfect squares. Well, 12 is not a perfect square, so this doesn't factor further. This one, although k squared and 4 are both perfect squares, this is an addition sign, so you cannot factor that further. So it looks like this is going to be our final answer for number 3. Okay, so number 4, there's actually 2 different ways you can do this one. So let me just slide this over to give myself a little bit more room. Okay, so the first way, you could start it, the same way we started the last example. What you can do is you can rewrite this expression so that the exponents are in descending order. So here, a to the 8th comes first, and this one doesn't even have an a, so that would come second. So if you want to do it this way, you could rewrite this as, make sure you keep the sign with the term, -3 a to the 8th, and then we have a positive 48. Okay, now after that, you can factor out the greatest common factor. So here, the biggest number that divides evenly into 3 and 48 would be 3. Now, since your leading coefficient, since your first term is a negative, you always want to factor out the negative. Okay, and keep in mind, if your first term was a positive, you would factor out a positive 3. But since it's a negative, we're going to factor out a -3, which leaves us with positive a to the 8th, and then, positive 48 divided by -3 is -16. Okay, now here we could factor further because this is a difference of perfect squares. Remember, if a term with an exponent has an even exponent, right? If you have an even exponent, it is a perfect square. So we can factor this further. I'm going to bring the -3 down. And since it's a difference of 2 perfect squares, I'm going to set up 2 sets of parentheses. And the square root of a to the 8th is a to the 4th, because a to the 4th times a to the 4th gives you a to the 8th. Okay, remember you add those exponents. All right, then we're going to make 1 plus and 1 minus. And the square root of 16 is 4. Okay, so this is what we have. All right, that's supposed to be a 4. It kind of looks like a Y. All right, so you want to look and say, all right, if I have 2 terms within a parenthesis, is it a difference of perfect squares? Now, this one's an addition sign, so that can't be a difference of perfect squares. But this is a difference. And look at this. If we have an even exponent, it's a perfect square. And also 4 is a perfect square, so this we're going to factor even further. Now, I want to remember to bring down my -3. And since a to the 4th plus 4 can't factor further, I want to bring that down. And then I'm going to take this, I'm just going to put arrows. I didn't have to do that, but I'm going to separate that into 2 more parentheses. Okay, so the square root of a to the 4th is a squared, so I'm going to put that in the first spot in each parenthesis. We can make 1 addition and 1 subtraction. And then the square root of 4 is 2. So we're going to put a 2 in the second spot in each parenthesis. And then you want to still look and say, well, do I have a difference of perfect squares since all of these parentheses can only contain 2 terms? So that's not a difference. Nope. That's not a difference because, right, if there's addition signs. This is a difference. And although a squared is a perfect square because there's an even exponent, 2 is not a perfect square. Nothing times itself gives you 2. So that lets us know we could stop factoring. This is our final answer. Okay, so now the other way you could do it is, let me just kind of put an arrow. All right, instead of, when you have 2 terms, all right, see how there's only 2 terms here? A lot of times you're going to be looking for greatest common factor and then dots. So if you don't want to rearrange the order of these 2 terms, you don't have to. Like, so for example, in number 3, let me just scroll back to that. See how the first thing we did was we rearranged the order so that we had our biggest exponent first, and then we did our next biggest, and then the least, right? These exponents went in descending order. When you have 2 terms, I mean, you don't have to do that if you don't want. It's up to you, however you prefer. You could just jump right into saying, all right, what's the greatest common factor? What could I pull out of both of these 2 terms? Well, 3. And this time I'm going to pull out, if I don't rearrange order, I'm going to pull out a positive 3 because our leading coefficient is a positive number. So if I pull out a positive 3, that'll leave me with, all right, 48 divided by 3 is 16. And then I'm going to bring down my minus sign. I had a 3, but I took it out, but I still have to put this a to the 8th on the other side of the subtraction sign. Okay, now, here, you want to look within your parentheses. Since we have 2 terms, is this a difference? Yes, it is, of perfect squares. Yes, it is. Both of these are perfect squares. So we could take the 3 and bring it down. You can open up 2 sets of parentheses. And since the square root of 16 is 4, we're going to put a 4 in the first spot in each parentheses because the 16 came first. We're going to make 1 plus and 1 minus. And we talked about before, the square root of a to the 8th is a to the 4th. So since this comes second within the parentheses, we're going to put that second within each of these parentheses. Okay, and then you're going to look and say, well, can I factor further? Since these both have 2 terms, the only thing you could really do would be dots. This is not a difference of 2 squares because it's not a difference, it's an addition sign. But this is a difference, and 4 is a perfect square, and so is a to the 4th. So we're going to factor further. So I'm going to bring down the 3. I'm going to bring down the 4 plus a to the 4th because that cannot factor further. And now this right here is what I'm going to break up into 2 separate parentheses. Okay, this is dots. So since the square root of 4 is 2, I'm going to put a 2 in the first spot in each parenthesis, make 1 addition and 1 subtraction. And since the square root of a to the 4th is a squared, I'm going to put an a squared in the second spot within each parenthesis. And then again, you want to look and say, can I factor further? Well, we don't have a difference, we don't have a difference. And although this is a difference, 2 is not a perfect square, so I can't factor further. So this would be my answer. Okay, so you could do it either way. I know these answers look different because this has a positive 3 factored out and this has a negative 3, and these are kind of like in reverse order as these. But if you were to, multiply everything out, these 2 expressions are equivalent, so either answer is acceptable. Okay, so let's take a look at number 5. And number 5, just like number 4, you could do one of 2 ways, okay? If you would like to reorganize these, so the term that has the exponent on it, right, the variable with the exponent comes first, you can totally do that. So if you want to reorganize this, reorder it. So it says negative 256 x squared, and then positive 100, so plus 100, you can do that. And then you would look at these 2 terms, and you would say, can I factor out a greatest common factor? Well, 4 divides evenly into both of these. That's actually the biggest number that divides evenly into both these numbers. But because my first term is negative, right, we say the leading coefficient is negative, instead of pulling out a positive 4, we're going to pull out a negative 4. Okay, so negative 256 divided by negative 4 is positive 64. And I'll bring down the x squared with it. And then positive 100 divided by negative 4 is negative 25. Okay, and then we could just look in our parentheses and say, is this dots? Is this a difference of 2 squares? I'm just going to move this up a little. So yes, it is. We have a difference, right, a subtraction sign, and this whole term is a perfect square, and so is this term. All right, so we know when we factor dots, we set up 2 sets of parentheses. Now, don't forget to take this negative 4 and bring it down. So let's do that right off the bat so we don't forget. And then the square root of 64 is 8, and the square root of x squared is x. So we can put in 8x in the first spot in each parenthesis. Let's make one addition and one subtraction. And then the second term within our original parenthesis, the square root of that is 5. So we're going to put a 5 in the second spot within each parenthesis. Okay, so then you want to look in your parentheses. Since there's only 2 terms, the only thing we're really looking for is the difference of 2 squares. This is not a difference. And although this is, neither term is a perfect square. So this would be our final answer. Now, if you prefer to do it the other way, okay, if you prefer, let me just change colors here. So we're going to come down here. Let me rewrite the question. 100 minus 256x squared. Whenever there's 2 terms, you do not, if you don't want to, you do not have to reorder them so that you have, the term with the biggest exponent first. You don't have to. If you want to, you can. So we could jump right into saying, all right, what's the greatest common factor? Well, I could pull out a 4. And this time, since my term in front is positive, right? What I see first, if that's positive, we're going to factor out a positive 4. Which leaves me with, well, 100 divided by 4 is 25. And then minus 256, or I'll just say 256 divided by 4 is 64, okay? Because I already brought down that minus sign. And then also I need to include that x squared that we didn't factor out in there. Okay, so then we just look in our parentheses and say, do we have a difference of perfect squares? Yes, we do. So I'm going to bring down my 4. I'm going to open up 2 sets of parentheses. This time, the way I'm doing this, I have the 25 first. So the square root of 25 is 5. So I'm going to put the 5 in the first spot within each parenthesis. Okay, we're going to have one addition and one subtraction. And then the square root of 64 is 8, and the square root of x squared is x, so we're going to put in 8x in the second spot within each parenthesis. And then when you look in your parentheses, since they both have 2 terms, you want to say, can I factor further? Is it dots? Again, for the same reason as above, this is addition, so it's not difference. And although this is a difference, neither one of these is a perfect square, so this would be our final answer. Okay, so you could either have your answer like this, or you can have your answer like this. Both of these 2 answers are equivalent to each other. All right, so let's take a look at number 6. Now, number 6 has 6 terms. So with 6 terms, you could either break it up into 2, 2, and 2, or into 3 and 3. Now, if you try to break it up into 2, 2, and 2, I'm sure a lot of you guys can see right out that here, if you factored out a 4m squared, it would leave you with 4m plus 1. And here, you'd have to factor out, I guess, a negative 10m, which would not leave you with 4m plus 1. It's not going to leave you with the same thing in the parentheses. So if you try to break it up into 2, 2, and 2, you could try it if you want. You'll run into a dead end. So instead, I'm going to break it up into 3 and 3. Now, one thing I should have mentioned first, before you start any question, any factoring problem, you want to look and say, can I factor out a greatest common factor? And I really can't, because this doesn't have an m, so I can't factor out m's. And other than 1, there's no number that divides evenly into all 6 of these terms. Okay, so that's why I started by grouping. Okay, now out of the first trinomial, out of the first three terms, it looks like I could factor out a 2 and an m. Okay, 2 is the biggest number that divides evenly into all three of them. And the reason I can only take out one m is because this term right here only has one of them. All right, so then I'm going to write what I'm left with in parentheses. So 16 divided by 2 is 8. And I had 3 m's being multiplied together, and I took one of them out, so it leaves me with 2 m's being multiplied together, so m squared. Then I'll bring down my plus sign, and 4 divided by 2 is 2. And I had 2 m's being multiplied together, and I took one of them out, so it leaves me with 1 to put in the parentheses. And then negative 30 divided by 2 is negative 15. And I had an m, but I took it out, so there's no m's left to put here, so I'm going to close up my parenthesis. Okay, so now if we look at our second trinomial here, we could see, it looks like the only thing we could factor out is a 5. We can't even factor out an m because this doesn't have an m. So I'm going to factor out a positive 5. Make sure you don't just write 5, right? You want to write plus 5. All right, all of this should be separated from what we're going to write here by an addition sign. Okay, so then in parentheses, so 40m squared divided by 5 is 8m squared. Okay, we didn't pull out any variables, so the variables with their exponents are going to stay the same. 10m divided by 5 would be positive 2m. And then negative 75 divided by positive 5 would be negative 15. And if we look, we have the same thing in our parentheses. So I'm first going to group together in one parenthesis, the 2m plus 5. So that's one of our factors. Now I'm going to rewrite this common trinomial that we see here and here, but we know we write that only once. So 8m squared plus 2m minus 15. All right, so now I want to look and say to ourselves, can we factor further? If we have two terms, we're looking to see if we have a difference of perfect squares. Well, this is definitely not a difference of perfect squares. We have an addition sign and nothing is a perfect square. So this doesn't factor further. All right, now if we look here, we have three terms, a trinomial. So with a trinomial, we would either do the add multiply method if this leading coefficient was a 1, but since it's not, we're going to have to do the rainbow, which, you know, helps us to create 4 terms, and that way we can group them. Okay, so what I'm going to do is let me first just bring this 2m plus 5 down so we don't forget about that. And then with this, okay, what we're going to do is we're going to bring down our first term. I'm going to leave a big space, and I'm going to bring down my last term. And we're going to come up with 2 numbers that multiply to the rainbow number. So they're going to multiply to negative, where can I fit this? Right here, I guess, negative 120. So they're going to multiply to negative 120, and they're going to add to positive 2. Now, this is actually not that bad because when you see the number 120, I mean, right, what pops out at me right away is 12 times 10, okay? And since they're going to multiply to a negative, they're going to have the opposite signs. So a positive 12 and a negative 10 would add to positive 2. Okay, so we're going to have a positive 12 and a negative 10. And because this term has an m, right, what we're doing is we're splitting this positive 2m up into 2 terms that if you did combine would give you this original term. So since this contains an m, we need to put an m on each of these. So this would be positive 12m and negative 10m. By the way, if you couldn't come up with these 2 numbers in your head, you can always use the calculator trick. If you forget how to do that, I guess if you scroll back to the explanation of number 1, I showed you how to use the calculator in that. Okay, so anyway, let's bring down the 2m plus 5. And then within our parentheses here, we are going to group. So out of the first 2 terms, we could pull out a 4 and then an m. And when we do, that'll leave us with 2m plus 3. Okay, 8 divided by 4 is 2. We had two m's being multiplied together. We took one out, so we still have one left. 12 divided by 4 is 3. We had an m, but we took it out, so we don't put an m here. Okay, now out of these two terms, you could either factor out a positive 5 or a negative 5. But if we want to be left with a positive 2m and a positive 3 in the parentheses, we need to pull these negatives out. So we're going to factor out a negative 5. And then negative 10m divided by negative 5, right? A negative divided by negative is positive, so it's positive 2m. And then negative 15 divided by negative 5, negative divided by negative is positive 3. So we can close that up. And then we also, if we open a parenthesis here, we should also close that at the end as well. Okay, so I'm going to bring down my 2m plus 5. I'm going to group together the 4m and the minus 5 into one parenthesis. And then I'm going to rewrite this common binomial factor that we see there of 2m plus 3. And it looks like this is going to be my answer because when you have two terms, right, as long as you factored out all the greatest common factors from the beginning, the only thing you could do to factor further with two terms would be dots, and none of these are difference of perfect squares. So that's our answer for number 6. All right, so if we take a look at number 7, what you'll notice right away is these terms are not, we have to rearrange our terms in standard form, okay? The exponents are not going in descending order. So this is the term with our biggest exponent. We're going to write that first. And make sure to keep the negative with this term. So this will be negative 3x to the 5th. And then this is the term with the next biggest exponent, and that's a positive 30x cubed. So plus 30x cubed. And then finally, the negative 72x, or the minus 72x, is going to go at the end. Okay, so now that we've rearranged, we want to say, well, can we pull out a greatest common factor? Yeah, we totally can. So 3 divides evenly into all these numbers, but since our leading coefficient, right, the number in front of the first term is a negative, we always want to pull out a negative. You always pull out the sign of what's in front of your first term. So we could pull out a negative 3. And then in addition, we can pull out an x. All right, so when we do, negative 3 divided by negative 3 is positive 1. If you want to put that there, you can. We had 5 x's being multiplied together, but we took one of them out, so that leaves us with x to the 4th. Now be careful with your signs here, because positive 30 divided by negative 3 is negative 10, right? A positive divided by a negative is negative. And then we had 3 x's being multiplied together, but we took one of them out, so it leaves us with 2 x's being multiplied together, which we write as x squared. And then again, be careful with your signs. A negative divided by a negative is a positive. So negative 72 divided by negative 3 is positive 24. And then we had an x over here, but we took it out, so we don't put it here. So let's just close up the parentheses. Okay, so now we want to say, can we factor further? So now we have a trinomial, okay? With a trinomial, if your leading coefficient is a 1, you do not have to do the rainbow. Can you do the rainbow? Yes. But I don't recommend doing it because it's just, taking more time. And when you're in a test situation, it's timed. Once that period ends, that's it. So you want to make sure you finish the question. So I wouldn't do the rainbow when you don't have to. So if there's a 1 in front of the x to the 4th, all we do is we set up 2 sets of parentheses. And since this is the x to the 4th, we're going to put an x squared in the first spot in each parenthesis. And you're going to come up with two numbers that add to negative 10 and that multiply to positive 24. All right, so if they multiply to a positive, they have the same signs. So since they add to a negative, they both have to be negative. And then just two numbers that multiply to 24 and add to negative 10 would be negative 6 and negative 4. And please do not forget to bring this negative 3x down. Anything that doesn't factor further comes right down. Okay, so we want to look and say, well, can we keep factoring? Now we're left with binomials. With a binomial, as long as you factor out the greatest common factor from the beginning, the only thing you're looking for is dots. Okay, they both have a difference. Now, this and this, these are both perfect squares, so this is a difference of perfect squares. The reason why this is not a difference of perfect squares is because 6 is not a perfect square. Nothing times itself gives you 6. Okay, so what I'm going to do is I'm going to bring down the negative 3x. I'm going to bring down the x squared minus 6 because those are what didn't factor further. And we're just going to break this up using dots. So to factor using dots, you set up 2 sets of parentheses, and you put the square root of this first term in the first spot in each parenthesis. So the square root of x squared is x. You make one addition sign and one subtraction sign, and then you put the square root of the second term in the second spot in each parenthesis. So the square root of 4 is 2. Okay, we already said that this can't factor further, this can't factor further, so now we're just looking at these. Okay, neither one of these is a difference of perfect squares, and when you have two terms, that's really all you're kind of looking for. So this right here would be our final answer for number 7. All right, so let's take a look at number 8. Okay, so number 8 has 4 terms. And if I look ahead, I see that we have c to the 4th, c cubed, c squared, and then a c. So our exponents are going in descending order. So they're, in the order we'd like them to be in. So now let's look. And if we have 4 terms, we know we're going to be doing grouping. But if you look ahead, look at this. All of these numbers are divisible by 3. We can pull out a 3. And in addition, since each term has a c, we can pull out a c. All right, so I'm going to pull out a 3c. All right, so that's going to leave me with c to the 3rd plus 4c squared, and then minus 9c minus 36. Okay, let me just make that c a little better. There we go. All right, so now that I factored out the greatest common factor, now I'm going to do grouping with what's inside the parentheses here. Now, remember with grouping, okay, how I like you to do it is I like you to kind of use a little square bracket or just show that you're grouping together the first 2 terms and then show that you're grouping together the next 2 terms. It just helps you to organize what you're looking at. All right, so let me bring this 3c on the outside down, and then I'm going to open a parenthesis. Or if you prefer to use a bracket instead, you can do that. And then we're going to look at these first 2 terms and say, well, what's the greatest common factor? Well, the only thing I could pull out is a c squared. Okay, you could write 1c squared if you want, but I'm going to just write c squared. And then in parentheses, that would leave me with a c plus 4. Okay, and again, if you don't like to have parentheses within parentheses, you can always use a bracket. That's okay. All right, now if we look at these 2 terms, we could see the biggest number that divides evenly into 9 and 36 is 9. So we're either going to have to pull out a positive 9 or a negative 9. And this is how you tell. If you look within these parentheses, see how this sign goes positive, positive, and this goes negative, negative. This has the opposite signs. If these have the opposite signs of what's in your parenthesis, it means you want to pull a negative out. So instead of factoring out a positive 9, we're going to pull out a negative 9. Okay, and don't forget, you always need a sign in front of this number. If you pull out a negative, you write a minus sign. If you pull out a positive, you put a plus sign. All right, so then in parentheses, we're going to have, negative 9 divided by negative 9 is 1. And I still have the c here, so I'm going to bring that down. So I have 1c, which I'm just going to write as c. And then negative 36 divided by negative 9 is positive 4. And then I can close that parenthesis, as well as, look, we have an open parenthesis here, so let's close that as well. And what you'll notice is, within the parentheses, it says the same thing. So that's good. That lets us know, all right, we're on the right track. All right, so now I'm going to bring my 3c down. And then I'm going to group this c squared with this minus 9, okay? You're going to group together the 2 terms that are in front of this common binomial that we see here. All right, so we have c squared minus 9. And then we're going to bring down that common binomial, and that's our final factor, okay? C plus 4, okay? So this, you just rewrite once. Now, you always want to look ahead and say, can I factor further? Now, since both of these are only 2 terms, the only thing we're really looking for at this point is dots, a difference of 2 squares. And this one is a difference, and both of these are perfect squares, so this can factor further. Okay, this one can't. First of all, we have an addition sign, and also c is not a perfect square. It would have had to say c squared. All right, so I'm going to bring my 3c down, I'm going to break up the c squared minus 9 into two separate parentheses. And since the square root of c squared is c, I'm going to put that in the first spot in each parenthesis. You know, we make one addition, one subtraction. And since the square root of 9 is 3, we're going to put a 3 in the second spot in each parenthesis. And then you could just take this c plus 4, and since it doesn't factor further, you bring it down. And if you try to say to yourself, do I have any more difference of perfect squares? I do not, so that means I am done. All right, if you take a look at number 9 is the same exact thing. I don't know what I was thinking here. It's the same exact thing as number 7, so I'm just going to skip right over that one. If you had trouble with number 9, I guess just rewind a little bit and just see what I did in number 7. All right, so let's take a look then at number 10. All right, this one looks a little tricky. We have x's and y's with exponents. All right, so let's see. We know that, now first of all, if you want to see if this is in the correct order, when you have more than one variable, right, just look at them alphabetically. X comes before y in the alphabet. You want to see if that first variable, if the exponents are going in descending order. So if we look at the x's, we have x to the 4th, and then x squared, and then technically x to the 0 because there's nothing here. So they are going in descending order. So this is the order we want our terms in. All right, but we still want to look and say, can I factor out a greatest common factor? Now, we can't factor out any variables because this term doesn't contain an x, and this term doesn't contain a y. But if you look at those numbers, you can factor out a 2, right? They're all even. And 2 is the biggest number that divides evenly to all of them. So let's do that. So I'm going to factor out a 2, which is going to leave me with 6x to the 4th minus 7x squared y squared, and then minus 3y to the 4th. All right, so now if we look here, we have a trinomial. And the number in front of our first term, we call that the leading coefficient. So the leading coefficient of our trinomial is something other than a 1. So since it's something other than a 1, this is where we do the rainbow. Oop, I went a little too far on that. And, it's going to lead us into factor by grouping. So now, with this, to find the rainbow number, we multiply this first coefficient with this last coefficient. So I went a little too far with my rainbow. I should have really just went to this number right here. So 6 times negative 3 is negative 18. Okay, I'm going to leave that there for a minute. Now, I'm going to take this 2 and bring it down. And we know when we do factor by grouping, we bring down the first term, we leave a big space, and we bring down the last term. And then we'll worry about breaking this up in a minute. So I'm going to first bring down my first term, so 6x to the 4th. Let me leave a big space, and I'm going to bring down my last term, which, don't forget the sign with it, it's a negative 3y to the 4th. Okay, so now what we have to do is we have to come up with two numbers that add to negative 7, and they're going to multiply to this rainbow number of negative 18. Okay, so it looks like we're going to have a negative 9 and a positive 2. So a negative 9, and I'm just going to put the numbers first, and a positive 2. Now, keep in mind, whatever variables are attached to this middle term, you need to attach to the negative 9 and the positive 2. So we're going to put x squared, y squared next to them. And I mean, the reason for that is because, think about it, this expression should be equivalent to this expression, which should be equivalent to this expression, right? As you work your way through a problem, every expression should be equivalent to each other. So if I were to combine my like terms right here, negative 9x squared y squared plus 2x squared y squared, that would give me what I had in the previous step, negative 7x squared y squared. So that's why we have to keep those variables on those numbers. All right, anyway. All right, so I'm going to bring down the 2. And from here, I'm going to group together the first two terms and group together the last two terms. So out of the first two terms, I could pull out a 3 as well as an x squared. So 3x squared. And when I do, I'm going to have to open another parenthesis. That's a squared, by the way. When I do, 6 divided by 3 is 2. And I had 4 x's being multiplied together. I took 2 of them out, so I still have two x's being multiplied together. And then I'll bring down the minus sign. 9 divided by 3 is 3. My pen's not really working well anymore. Here we go. And then I have an x squared, but I took it out, and I didn't take out any y, so this y squared has to come down as well. All right, so let's close that up. Now, if we look at the last two terms, I mean, numerically, you're really just taking out a positive 1, and then we can't take out any x's, but we can take out two y's, right? They both contain y's, and this one only has 2, so we can't take out more than that. So really what I'm taking out here is a y squared. Now, please don't just write y squared. Okay, we're taking out a positive y squared. Remember, this sign is important because you're separating this from what we're going to write over here with an addition sign. All right, so I'm going to open up my parentheses. So out of the first term here, I took out the y squared, so I still have this 2x squared. And then here, I'm just going to bring down the minus 3 because we didn't take out anything other than 1. And we had 4 y's being multiplied together, and we took 2 of them out, so we still have 2 to put in the parenthesis. And then I'm going to close this parenthesis as well as close up that parenthesis. Okay, so it looks like we're on the right track because this matches this. All right, so let me just bring my 2 down. And then I'm going to group together the 3x squared, what's in front of this parenthesis, with the y squared, with the plus y squared, what's in front of this parenthesis. So we have 3x squared plus y squared. And then I'm going to take this common binomial that we see, and that's going to be our next factor. We only write it once, remember. 2x squared minus 3y squared. Okay, so now we want to look and say, look, we have 2 terms here and 2 terms here. Is either one of them a difference of perfect squares? Well, this is not a difference, so we can't do anything with that. This is a difference, and although our variable terms are perfect squares, 2 is not a perfect square, and 3 is not a perfect square, so it looks like this is our final answer. All right, number 11. All right, with number 11, we again have 4 terms. So, I mean, you could look at this, right? And you could say, all right, well, look, I could factor a 4 out of each of these terms. Okay, you can jump right into that. But before I do so, I notice here that our x cubed, the biggest exponent, is here. And then over here is our x squared. Then over here is our x, and then here's our number. Why don't we first, I always find it easier to first rearrange. Why don't we first rearrange these so that our exponents go in descending order? Okay, we want to write this in standard form. We want to have the term with the biggest exponent first, so 4x cubed. Then the term with the next biggest exponent, which is this, the positive 8x squared. And make sure you keep the sign with the term. Then we're going to have the minus 8x. And then this right here, really, I mean, if you don't see an x, you could think about it as x to the 0. There are no x's. So we're going to bring down the minus 16 at the end. Okay, now I'm going to factor out the greatest common factor. 4 divides evenly into everything. So I'm going to first pull out a 4. I mean, if you don't take out the greatest common factor in the beginning, you can do it later, but it's just easier to do it in the beginning because then you're dealing with smaller numbers throughout. And also, chances are, if you forget to do it in the beginning, you know, there's a good chance you may forget to do it in the end. So I would just always look for that right when you start. Okay, so I just divided everything by 4. So this became a 1. 8 divided by 4 is 2. Same thing here. And 16 divided by 4 is 4. Okay, now I'm going to get into grouping. So let me bring this 4 down. And I'm going to bring this parenthesis down. And I'm going to group together the first 2 terms and group together the next 2. Okay, out of the first 2 terms, I could pull out an x squared. And that will leave me with x plus 2. And then in the next 2 terms, well, you have to decide, do I want to factor out a negative 2 or a positive 2? Well, since in this parenthesis, both terms are positive, right? Plus, plus, we want to be left with both terms being positive in the parenthesis here. So in order to get both terms to be positive, we need to take these negatives and factor them out. So we're going to factor out a negative 2. Okay, and then negative 2x divided by negative 2 would be positive 1x, which I'm just going to write as x. And then negative 4 divided by negative 2 is positive 2. And then let's close this parenthesis as well as this parenthesis. All right, so then these two match up. So that's great, okay? We know, all right, we're on the right track. All right, so let me bring my 4 down, and then I'm going to group together the x squared and the minus 2. Okay, we're going to group together what's in front of these common binomials. So let's put them in one parenthesis. So the x squared minus 2. Okay, we just put that there and put that next to it. And then we're going to rewrite this common binomial that we see, but just once. Okay, so let's look. Can we factor further? Well, here we have a difference, and this is a perfect square, but 2 is not a perfect square. And then this is not a difference, and nothing is a perfect square, so we can't factor further. So that's it. That's our final answer. All right, on to number 12. All right, so number 12, we have 4 terms. Now, some of you may look at this and say, oh, let me just jump right into factor by grouping, right? There's no greatest common factor that I could take out of all of these 4 terms, so let me just jump into grouping. Okay, if you try that, you actually are going to run into a dead end, and this is why. We have to first rearrange our terms. So if you have more than one variable, right, we have x's and we have y's. Whichever variable comes first in the alphabet, we would like those exponents to go in descending order. So see how this is x to the 3rd, and here's my x squared, and here's my x to the 1st, and then this one doesn't have any x's. That's the order that we want to rearrange the terms in. So x to the 3rd, x squared, x squared, x to the 1st, and then x to the 0 power. All right, so let's first write our 20 x to the 3rd. Okay, and then the next biggest exponent on our x's is this one right here, x squared. So we're going to put this term next, the plus 8x squared y. And then this is x to the 1st. This is the next, exponent when we go in descending order. So we're going to write minus 5xy squared. And then finally, this one has no x's. So we're going to write the negative 2y cubed last. Okay, so again, if there's more than one variable, you want to look at alphabetically which one comes first. So x comes before y, and you want those exponents to go in descending order. Okay? All right, so now we already said there's no greatest common factor for all 4 of these terms. Okay? This doesn't have any x's. This doesn't have any y's. Other than 1, nothing divides evenly into all these numbers. So we're going to jump right into grouping. So at this point, it shouldn't be too bad. We'll group together the first 2 terms and group together the last 2 terms. So out of the first 2 terms, we can pull out a 4 as well as an x squared. And when we do, 20 divided by 4 is 5. And I had 3 x's being multiplied together, but I took 2 of those out, so I still have an x to put down here. All right, and then plus 8 divided by 4 is 2. I had x squared, but I took them both out. But I still have this y here, so I need to bring that y down. Okay, so now, when we look at the next 2 terms, what you'll notice is the only thing that you can pull out is a y squared, right? Other than that, can't pull out any x's or really a 1 or a negative 1. All right, so let's figure out, are we going to be pulling out a positive 1 y squared or a negative 1 y squared? All right, we'll see how this goes positive, positive. This goes negative, negative. This has the opposite signs of what we have here. And remember, we want to be left with, within our parenthesis down here, the same thing that we have here. So if we want to be left with positive, positive within our parentheses, we need to factor these negatives out. So let's factor out. You could write negative 1y squared. I'm going to just write negative y squared. Okay, and then that way, a negative divided by a negative is going to be a positive. So if I pulled the negative out as well as the y squared out, don't I still have this positive 5x? Okay, And then here we have, I'm going to do it like this. We have negative 2 divided by a negative 1, which is positive 2. And we had 3 y's being multiplied together, and we took 2 of them out, so we still have a y to put down here. And then close up your parentheses. And look at this. Again, our parentheses match, so we know we're on the right track. All right, let's group together what's in front of the parentheses. So the 4x squared minus y squared. Okay, and then we're going to take this common binomial that we see and rewrite it once. Okay, so now let's look and say, well, we have 2 terms and, another 2 terms. So with 2 terms, you're just looking for dots. Do we have a difference of perfect squares, difference of 2 squares? Now, this is not different, so let's just rule that out. Here's a difference. And if you look, this term is a perfect square, right? The square root of 4 is 2, and the square root of x squared is x. And this term's a perfect square. The square root of y squared is y. So we could take this parenthesis and break it up into 2 parentheses and factor it using dots. Okay, so we're going to put the square root of this first term in the first spot in each parenthesis. And let's make 1 addition and 1 subtraction. And then we put the square root of the second term in the second spot in each parenthesis. Okay, and then let's just take our final factor here and just bring it down. All right, let's see if we can factor further. Well, we have all binomials here. The only one with the subtraction sign is this one. This is the only one that has the difference. But this is not a perfect square, and this is not a perfect square. So we know we are done. All right, so let's take a look at number 13. Now, even though this is multiple choice, this is a lot of work because you have 4 factorizations to check out. Okay, so let's just get started with the first one. Okay, so we have 6 terms here. So we know with 6 terms, we're either going to have to break it up into 2, 2, and 2, or we're going to have to break it up into 3 and 3. Now, some of you can see right off the bat that if you were to break it up into 2, 2, and 2, and factor out the greatest common factor, you wouldn't have the same numbers left in the parentheses. I mean, you could kind of see how this number is bigger than this number, right? The first term is bigger than the second term, but look at the coefficients here. The first term is smaller than the second term. So if you factored out a greatest common factor, you wouldn't be left with the same thing in parentheses. I mean, you could try it out if you can't see that. Sometimes it's hard to just look and see ahead. But if you tried to break it up into 3 groups of 2, you would not be left with the same thing in the parentheses. Okay, so then I'm going to break it up into 2 groups of 3. Now, out of this first group, the only thing I can factor out is an x. All right, so let's do that. I'll factor out an x, and that's going to leave me with 2x squared minus, just 1x now, and then minus 3. Okay, here, we took this x and pulled it out, so we're just left with a number. Okay, now when I look at these terms, we can't factor out any variables, but we can factor out a 3. And we're going to factor out a positive 3, because see how within my parentheses it goes positive, negative, negative? And doesn't this follow the same trend with the signs, positive, negative, negative? So we don't want these signs to change. If you don't want the signs to change, you always factor out a positive. So I'm going to factor out a positive 3, which is going to leave me with positive 2x squared, and then minus 1x, which I'm just going to write as minus x, and then negative 9 divided by positive 3 is negative 3. Okay, so now let's take what's in the front of our parentheses, the x and the plus 3, and we'll group that together in one parenthesis. And now let's take this common trinomial and rewrite that. Okay, so let's say, can we factor further? Well, this binomial we can't because there's no difference and there's no perfect squares. But this trinomial, let's see if we can, okay? Now, if there's a number other than 1 in front of the x squared, we're going to have to do the rainbow into factor by grouping. Okay, so let me first just bring this x plus 3 down. And we know whenever we have to do the rainbow into factor by grouping, we bring down the first term. We're going to leave a big space here because we got to break that up into 2 terms, and we're going to bring down the last term. All right, now we need to come up with 2 numbers that multiply to -6. So they're going to multiply to -6. And this in here is really a -1. So they're going to add to -1. Okay, so 2 numbers that multiply to -6 and add to -1 would be +2 and -3. So I'm going to have a +2. And since this is an x, we have to put an x on it. So a +2x and a -3. And again, don't forget to put the x on it. All right, so now we're just going to group, right? We're going to group the first 2 and group the next 2. All right, let's take this x plus 3 and bring it down. And out of the first pair of numbers, we could factor out a 2 as well as an x. All right, so let me open up another parenthesis, and I'm going to factor out a 2x. So when I take that out in parentheses, well, I took out this 2, and I took out one of the x's, so I still have an x to put in here. And then if I bring down the plus sign, 2x divided by 2x, anything divided by itself is 1. Okay, then we're going to close up the parentheses. Now here, in our last 2 terms, we could either factor out a +3 or -3. But keep in mind, in this parenthesis, we have a positive x and a positive 1. So we want to be left with a positive x and a positive 1 in the parenthesis underneath. So in order to be left with positives, we have to take this negative, or these negatives, and factor them out. So we're going to factor out a -3. Okay, and that does leave me with, well, -3 divided by -3 is +1. So we have positive 1x. And again, -3 divided by -3 is +1. All right, so I'm going to close that parenthesis, and I'm going to have to close the other parenthesis. All right, so I'm kind of running out of room here, but I'm going to squish it. All right, I'm going to bring down my x plus 3. I'm going to take the 2x and the -3 and put those together in one parenthesis. And I'm going to rewrite this binomial factor of x plus 1. All right, now I really probably shouldn't have written on the question because now we can't see the question, but we are looking for which one is incorrect. All right, well, let's look at this. This one, when we factored this, we wound up with an x plus 3, which we have right here. We wound up with a 2x minus 3, which we have right here. And we wound up with an x plus 1, which we have right here. It doesn't matter what order they're in. So this factorization is correct. Okay, so I'm going to cross off that one. That one checked out for us. All right, so now let's take a look at number 2. All right, so here we have 4 terms, right? And remember, if you have more than one variable, right, if you have x's and y's, you want to look at the variable that comes first in the alphabet and make sure that those exponents are going in descending order. So we have x cubed, x squared, x to the first, and then no x's. So this looks good. If we look at all of our terms, there's no greatest common factor that we could factor out, so I'm going to just jump right into factoring. So we're going to group and group. All right, out of the first 2 terms, we can factor out actually just an x squared, which is going to leave us with 5x minus 6y. Out of the next 2 terms, all right, let's see. Well, 9 is the biggest number that divides evenly into 45 and 54. And we can also pull out a y squared. So let me just write 9y squared for a minute. So 9y squared. Now we have to decide whether we want to make that positive or negative. Now let's think. In this parenthesis, our first term is positive and our second term is negative. So it goes positive, negative. Up here, it does the opposite. It does negative, positive. So if we want these signs to change, what that means is we have to pull out not a positive 9, but a negative 9. So we're pulling out a negative 9y squared. Okay, so then negative 45 divided by negative 9 is positive 5. And we pulled out the y squared, but not this x, so we have to bring the x down. Okay, and then positive 54 divided by negative 9 is negative 6. And we started off with 3 y's being multiplied together, and we pulled 2 of them out, so we still have 1 y left down here. And then let's close those parentheses. All right, so now we can group together what's in front of our common parentheses. So we could group together the x squared minus 9y squared in one parenthesis. And I'll bring down that common binomial that we see of 5x minus 6y. All right, so let's see, can we factor further? So when we have binomials, we're looking for differences, which they both have, and then perfect squares. The second parenthesis doesn't have perfect squares, but this first one does. Everything here is a perfect square. So I'm going to break this one up into two separate parentheses. All right, so the square root of x squared is x, so I'm going to put that in the first spot in each parenthesis. And we're going to make one addition and one subtraction. And the square root of 9y squared is 3y, so that goes in the second spot in each parenthesis. Okay, and then I'm going to bring down my 5x minus 6y. Now, if we look at all of our parentheses here, there's no difference of perfect squares, so we can't factor further. So let's just go to our answer here and see, did this wind up equaling this? Are they equivalent? Okay, so we have the x plus 3y right there, the x minus 3y right there, and the 5x minus 6y right there. All right, so this one checks out as well, so this is not our answer. Okay, now when I look at number 3, here, we haven't been taught how to factor this yet, okay? I mean, really, I don't see a greatest common factor that could factor out. I really don't see anything that we can do with this. You will eventually learn how to factor something like this in math, but not yet. So then how are we supposed to know if this is equivalent to this? Well, what we do know how to do is we know how to work with this side of the equation, right? Think about it. If you're multiplying two expressions, don't you just distribute the first term to all three and distribute the second term to all three? Let's do that, and let's see if we wind up with 8 to the 6 plus 27 when we combine our like terms. All right, so let's try this out. So I'm first going to distribute the 2a squared right here to all three terms. Okay, so let's do it. So 2a squared, I'm just going to kind of do this over here. Okay, so 2a squared times 4a to the 4th would be, well, we multiply the coefficients, so 2 times 4 is 8, and remember, we add those exponents. So that'll give us a to the 6th. So 8, a to the 6th. Okay, and then 2a squared times 6a would be, well, 2 times 6 is 12. And a squared times a squared is a to the 4th. Okay, and then 2a squared times 9, well, 2 times 9 is 18. And then we're going to stick that a squared on it. All right, let me just move this over a little because I think I might need a little more room. All right, now let's take the 3 and distribute it to all three terms. So 3 times 4a to the 4th would be 12a to the 4th. 3 times 6a squared would be 18a squared. And then 3 times 9 is 27. All right, it looks like we have a bunch of like terms that combine here. I highly doubt, when we combine these, that we're going to be left with, this little binomial right here. So let's just try it out though. All right, so the 8a to the 6th doesn't combine with anything because there is no other a to the 6th term. All right, this 12a to the 4th and this 12a to the 4th can combine to give us 24a to the 4th. Okay, this 18a squared and this 18a squared can combine to give us 36a squared. And then I'm just going to bring down the plus 27 at the end. Now, what you'll notice is that this is not equivalent to this. Okay, these don't equal each other. I'm going to put a slash to the equal sign. So this is going to be our answer. Now, it's always important to just make sure we check all of the other choices as well, because we could have made a mistake. All right, but if we look at this down here, choice 4, isn't this dots? It's a difference of perfect squares, and the square root of 100 is 10. There's one addition and one subtraction, and the square root of 49x squared is 7x. So number 4 doesn't work either. So choice 3 is our answer. All right, and now let's take a look at number 14. This is another one that I'm going to need some room to do because they again want to know which factorization is incorrect. So we got to go through them each one by one. So even though it's multiple choice, it's definitely more time consuming. All right, so let's take a look at choice one. Choice one, the first thing you want to say to yourself is, can I factor out a greatest common factor? Which we can't. So if we have two terms, we're looking for dots. Is it a difference? Yes, it is. Of two perfect squares. Yes, it is. These are both perfect squares. All right, so we can factor this. So basically, you set up two sets of parentheses, which they did, and the square root of 16 is 4, and the square root of x to the 16th is x to the 8th. Remember, when you have an exponent, you cut it in half. So we're going to put a 4x to the 8th in the first spot within each parenthesis. Okay, now let's look at what comes second. We have a 25. The square root of 25 is 5, so we put that in the second spot in each parenthesis. So choice one is correct. So we're looking for what is incorrect. So I'm going to cross that one off, okay? That's not our answer. All right, now choice two. Here again, we have two terms. And we cannot pull out a greatest common factor. And this is not a difference of perfect squares. Now, this is something actually called a difference of perfect cubes, which we did not learn how to factor yet. So what we're going to do instead, since I don't know how to factor this, I do know how to multiply two parentheses, right? If I want to multiply the right-hand side of the equation out, wouldn't I just distribute first the 3a squared to all three terms? And then wouldn't I distribute the negative 2 to all three terms? And then let's combine our like terms and see if it leaves us with what was on the left-hand side of the equation. All right, so let's do this. So 3a squared times 9a to the 4th would be 27 a to the 6th. Remember, you add those exponents. Okay, 3a squared times 6a squared would be positive 18 a to the 4th. And then 3a squared times 4 would be positive 12a squared. All right, so now let's distribute the negative 2 to all three terms. So negative 2 times 9a to the 4th is negative 18 a to the 4th. All right, I'm kind of running out of room, so let me just give myself a little more room. So then negative 2 times 6a squared would be negative 12a squared. And negative 2 times 4 is negative 8. All right, so let's try to combine some like terms. Now, let's see, this 27 a to the 6th. We don't have any other a to the 6th terms, so I'm going to bring that right down. 27 a to the 6th. Now, here I have a positive 18a to the 4th, and here I have a negative 18a to the 4th, so they're just going to cancel each other out. So these two terms cancel. All right, now here I have a positive 12a squared and a negative 12a squared. So again, those are just going to cancel. And it looks like I have a minus 8 at the end, so I'll bring that down. Now, if we look at this expression I'm left with, isn't this exactly what it says on the left-hand side of the equal sign? So what that means is these two expressions are equal to each other. So let me move this back over. Since they're equal to each other, we're looking for which is incorrect. So choice 2 is not going to be our answer. All right, let's take a look at choice 3. Okay, so I wrote it out here. In choice 3, we have 4 terms. And you first want to look and say, can I factor a greatest common factor out of everything? We can't, so we're going to just jump right into factor by grouping. So I'm going to group together the first two terms and then group together the last two terms. All right, out of the first two terms, it looks like I could factor out an 8 as well as an x. So if I factor out an 8x, then 56 divided by 8 is 7. And then I had two x's being multiplied together, right, x squared, but I took one of them out, so I still have 1 to put here. So 7x. Now let's bring down the minus sign. Now, 8x divided by itself. Anything divided by itself, I pulled the whole thing out. So anything divided by itself is 1. So I'm going to put a 1 there and close up my parentheses. All right, now to these two terms, once I factor out the greatest common factor, I'm hoping to be left with the same thing in parentheses down here as I have here. Now, if we look at this, we have a positive 7x and a negative 1. This says negative 7x and positive 1, so it has the opposite signs, right? This goes positive, negative, whereas this goes negative, positive. So since these have the opposite signs of what we have down here, we're going to factor out a negative 1 instead of a positive 1, and that way we should be left with the same thing in parentheses. So let's see. So negative 7x divided by negative 1 is positive 7x, and then positive 1 divided by negative 1 is negative 1. And look at that. These match up. They both say 7x minus 1. So we know we're going to take what's in front of each parenthesis, the 8x and the minus 1, and we'll group those together. And then we're going to take that common binomial of 7x minus 1 that we see and write it once. Okay, now let's see. We have an 8x minus 1, which is what it says on the right-hand side of the equation, and a 7x minus 1, which it also says on the right-hand side of the equation. So choice 3 is also correct. So that is not our answer choice. Now, I don't want you to right away circle choice 4, because we could have made a mistake, right? Everyone makes mistakes. So let's try out choice 4, and let's see if we get the same answer. All right, so here we have a trinomial. Now, because our leading coefficient is 1, please don't spend the time to try to do the rainbow and factor by grouping. If your leading coefficient is 1, all we do is set up 2 sets of parentheses. And in this example, we are going to put an x to the 4th in the first spot in each parenthesis because x to the 4th times x to the 4th gives us x to the 8th. Keep in mind when you're multiplying two terms with the same base, you actually add these exponents. All right, so now we have to come up with two numbers that multiply to give us 6 and that add to give us -5. And when we do, we're going to put it here and here. All right, so two numbers that multiply to +6 and add to -5 would be -3 and -2. So, this is the answer, because if we look here, this does not match up with this. So choice 4 is the incorrect choice. All right, we have 2 left to go. So number 15, express as the product of 4 linear factors. All right, now, I don't know if you guys remember, but see how in here, within this parenthesis, it says the same exact thing as it does within this parenthesis? All right, well, we're going to make our life a lot easier. What we're going to do is we're going to bring a different variable into it. You can call it y, you can call it a, you can call it whatever you want. Okay, I'm going to call it a. What I'm going to do is off to the side, and it's really important to write this. It's called a let statement. You're going to let a equal what we underlined there, so x squared plus 3x. So if you bring a different variable into it, you want to make a let statement. That way you're saying, this is what I'm letting a represent, okay? So wherever I see this in the problem, I'm going to replace it with what it's equal to, an a. All right, so I'm going to rewrite this as a squared minus 44a plus 160. Okay, again, since we said we're going to let a be x squared plus 3x, wherever we see an x squared plus 3x, see we see it there, I'm going to replace it with an a and bring down the squared. Then I'm going to bring down the minus 44, and look, I see another x squared plus 3x, so I replaced it with an a, and then I brought down the plus 160. Now this right here, this isn't so bad to factor. This is a trinomial where the leading coefficient is 1. So when that happens, we just set up 2 sets of parentheses. And since this is an a squared, I'm going to put an a in the first spot in each parenthesis. And then we're just coming up with two numbers that multiply to 160 and add to -44. All right, well, if they multiply to positive 160, right? If they multiply to a positive, it means they have the same sign. So it either has to be plus plus or minus minus. Well, since they add to a negative, it has to be minus minus. And then just, you may have to use your calculator, however you need to do it, but you need to come up with the two numbers that fit both of those criteria, and it winds up being -40 and -4. Okay, if you multiply these together, it gives you positive 160, and if you add these together, it gives you -44. Okay, so now what we're going to do is they want us to express this as the product of 4 linear factors. Now, first of all, we only have 2 factors. And then the other problem is, didn't the original problem really contain x's, not a's? So we need to now go back and switch these a's back to x's, okay? So wherever we see an a, since a equals x squared plus 3x, let's replace this a right here with an x squared plus 3x. Okay, now I'm going to bring down the parenthesis, bring down the minus sign, and bring down the 40. And then close that up. Now as we work our way over, right, you'll see, oh look, here's another a. Let's again replace this a with what it's equal to, which is x squared plus 3x. and then just bring down everything else. I'm going to bring down the parenthesis in front of it, the minus 4 after it, and the close parenthesis. Now we still have 2 factors. We need 4 factors. Linear, linear, all that means is you're going to have x to the first power. We don't have x to the first power. These, when you have x squared, these are called quadratic factors. So we have 2 quadratic factors. We want 4 linear factors. So it means we have to factor these further. All right, well, let's factor this. This is a trinomial where the leading coefficient is 1. So we can open up 2 sets of parentheses. And since we have an x squared here, I'm going to put an x and an x, the first spot in each parenthesis. And then we have to come up with 2 numbers that add to positive 3 and multiply to negative 40. All right, so if they multiply to a negative, we know they have to have opposite signs. So we're going to have 1 positive and 1 negative. And then the numbers that fit both of these 2 criteria here would be, let's see, positive 8 and negative 5. So as of right now, these are 2 linear factors. Now let's see if we can create 2 linear factors from this. All right, so again, we have a trinomial where the leading coefficient is 1. So I'm going to set up 2 sets of parentheses. And since this first term is an x squared, I'm going to put an x in the first spot in each parenthesis because x times x gives you x squared. And then we're going to come up with 2 numbers that add to positive 3 again, but this time they're going to multiply to negative 4. All right, again, if they multiply to a negative, we're going to have opposite signs, different signs, 1 positive, 1 negative. And then the 2 numbers that multiply to negative 4 and add to positive 3 would be positive 4 and negative 1. Okay, so this right here is our answer. We wound up with 1, 2, 3, 4 linear factors. All right, so finally, I'm going to just make this a little smaller. Oop, and I guess crooked, sorry about that. Let's take a look at number 16. It says the volume of a particular rectangular box is given by this equation right here. The height and length of the box are shown on the diagram. So the height and the length of the box are shown on the diagram. Find the width of the box in terms of x. Now they're giving us a clue. They said, remember that volume equals length times width times height. Okay, so they also gave us the volume over here, so I just wrote it down real quick. And if we think about it, if volume equals length times width times height. All right, if we were to take this and factor it, when you factor something, right, the factors are what multiplies together to give you that original expression. So if we factor this, we could figure out what times what times what gives us this expression. All right, so let's go for it. All right, so I'm just going to bring down the volume equals. Now, the first thing you want to do when you factor and expect, well, you could do one of 2 things. If you want, you can rearrange these terms so that you have the term with the biggest exponent first and then the term with the smaller exponent. When you have 3 terms, 4 terms, I mean, basically when you have anything more than 2 terms, I recommend always doing that. The only time that I say you don't necessarily have to do that is when you have 2 terms. I'm actually going to leave it like this. I'm going to leave it in this order. If you want to rearrange it, you definitely can. Okay, so first thing I'm going to do then is I'm just going to factor out the greatest common factor. So it looks like I could factor out a 2 as well as an x. All right, so let me factor out a 2x. And then that would leave me with, well, 50 divided by 2 is 25. And this x I already pulled out, so I don't have to put it in the parentheses. Then I'm going to take this subtraction sign and bring it down. And then 2 divided by 2 is 1, so if you want to put a 1 here, you can. And then I had 3 x's being multiplied together. We say x cubed, but I took one of them out, so I still have 2 x's being multiplied together, which we write as x squared. All right, so now I'm going to try to factor further. I'm going to bring my 2x down, and if you notice, this is a difference of perfect squares. So when that happens, I open up 2 sets of parentheses. And I'm going to put the square root of the first term in the first spot in each parenthesis. So the square root of 25 is 5. And then I'm going to make 1 addition and 1 subtraction. And then I'm going to make the square root of the second term, which is x, and put that in the second spot in each parenthesis. Okay, so again, the square root of x squared is x. Let's put that in the second spot in each parenthesis. Now, if you look here, they told us that the height and the length are given. So isn't this 2x right here? And isn't x plus 5 the same thing as 5 plus x, right? When you add two numbers, it doesn't matter what order you add them in. So this is the only component that they didn't show us in the diagram. So this must be the width. Okay, so we can write that our width is equal to 5 minus x. Okay, and that is our answer.